So hello everyone. In this part of the code, what we are supposed to do is use the DHT22 sensor in order to actually tell like when we need to blink the LED. Like if the temperature is above 25, we need the second LED to blink, and if the temperature is above 20, we want the first LED to stay on. So, and if the temperature is below 20, then we want the first LED to stop, and that's what we wanted to do. But the thing here we have to do is we have to work with the resolution of 0.01 second, which is 10 milliseconds. So that's what we are going to do, and there are two methods to do that. So first look onto our header file. Now header file has one setup for TC4. We need to deal with the timer. So the first is timer counter 4. Now why timer counter 4 and why not TC0, 1 or 2? Because all those three timer counter deals with PWM, and we don't want to, we just need something to work with our GPI opens for the user application. So TC4 and 5 is a better option. 4 just because it comes before 5 and we have an 4 option with us, so we can use that. And we need a 16-bit timer counter. So if we need a 32-bit timer counter, we can use the TC4 and TC5 along with that in order to make it a 32-bit counter. So the first option is like we can use our general clock 4 to get the 1 uh, megahertz from the uh, DFL48, and what is like it is a general clock that the Arduino works is, which is 48 megahertz, and dividing the, using the general clock 4 and dividing that with 48 will give us 1 megahertz. So we are using 1 megahertz clock now in order to get our time to be around 10 milliseconds. So that's what we are doing with. And the first thing is like we need a helper function, and what it actually done is like it keeps on checking the state of the timer. So it's on, and it checks like the synchronization of it. Then if you read up on the datasheet of SMD21, it says like the time counter for the peripheral isn't on. So this line of code on the time counter for the peripheral, and the first method is a so if condition, and we have the second method with the else condition. So let's look on to the first method, which is a, in which we are using the general clock controller 4 and here generator 4 in order to get the clock cycle of 1 megahertz. And as I talked about earlier, we would be dividing the FLL 48M with 48 in order to get 1 megahertz. So ID would be 4. Again, checking the synchronization and status bits, and then dividing it by 48. So division is done here. Again, checking the synchronization, enabling the generator 4. We need to see our general clock DFO again, and then enabling it. Again, checking the synchronization, routing the general uh, to the time counter 4 and C 5, and then again checking whether it is enabled or not. Now here comes the important part in which we have to assign a prescaler. So prescaler would be 1 in this case, and because we have already divided and we have 1 microsecond. And how do we get the count compare value to start from 0, and we know that it would be 10,000. Now, in order to do that, I have done the calculation over here. So, in order to get the particular number of ticks that we need is you need to know about the desired time. So, desired time was given to us about 0.01 seconds. So, that's what here it is. And the other thing is like the frequency that we are dealing with. So, we have reduced the frequency to be about 1 megahertz, which is here 6 zeros, and then dividing it with the prescaler. So prescaler is 1 in this case. So we get the value about reducing these. So, okay, I just wrote. So we have about 10,000 ticks with us. So we know that if we want to have a desired number about 10 milliseconds, we need to have 10,000 ticks. As you can see, so how did we get this number 10,000, and why -1? Because we are starting the count compare from 0, so that's why reducing it. So it will always be in -1, or you can just start it from 1 if you want, and then you can write it equals to 10,000. So starting it from 0 and then comparing whenever the text reaches that particular amount. Now, as we have done above, here comes the another part. Now we are using the generator number, whatever you like, and then we have this particular thing. Now, how did we have the text to be at this particular number? Now we are dealing with 8 microhertz, and the prescaler for this is 64. You can have different prescaler, but you need to select a particular one due to the calculation. Here, the 64 prescaler is which we are dealing with. So desired number is again 0, desired time is 0.01, and into like again the frequency that we are dealing with is 8 megahertz, and dividing it by 64, it gives us the value 1250. So when 1250 ticks actually happen, then it means we have passed about 10 milliseconds. That's what we want. So this is another option that we can deal with, and then resetting it. So this is to reset the software reset. It resets the bits for that particular counter, and again is configure the prescaler and matching the frequency, like everything is correct. Again, checking the flags, enabling those, checking if the condition is true, and checking whenever 10,000 milliseconds happen, checking what is working with, and okay. So we have past 10,000 milliseconds. Now resetting the timer. That's what it is done. Pins until that particular period of time. Now the functionality, how the LEDs are working, all those things are inside the .ini file. Now we have it's just the previous code that we always do with outsetting the output, setting it to so I'm working with DHT13 and B12. So DHT13 could be your person pin, or you can actually have another pin at that particular pin, and so that is for the port for the CMSIS. It is 17 and 19. That's what we are dealing with here. And setting those particular pins too high and leaving the other pin as it is. All those configuration it checks. Now we need to have the text check the samples of the HT whenever there are 3000 ticks. Now 3000 ticks into 10 milliseconds would actually gives us 30 seconds. So we're getting the sample rate of the sensor after 30 seconds. That was the requirement of the code. And it's just to display everything, and it toggles the LED again and again. So let's look into the circuit now. So the serial monitor, and let me just so this is the circuit. Let's just reset it. As you can see, this is the DHT22 sensor, and this LED seems to be glowing because the temperature is above 25, and obviously the first LED will be on if the temperature is above 20, and the second would blink if it is above 25. So that's what it is doing currently, and that's what's happening right now. Okay, if the wire disconnects something, okay, again resetting it stopped because the temperature doesn't seem to. I think it will be able to get the logic. Yeah. Okay, why doesn't this LED seems to be glowing? Oh, the wiring problem. There you go. The second LED is grows, and as you can see, we will get the reading after 30 seconds. So let's wait for 30 seconds to get the another reading for this. There you go. Okay, and you can play around with it. If you hold it for a couple of minutes, the temperature will rise, it will grow up to 32 something, and if you have something colder and wrap around your DHT22, the temperature will go low. So currently I have a blower, so the temperature won't be going down. So this is how you do it. Thanks for watching this video.